All right, so what are we actually doing at the moment? We are doing this thing called trigonometry. And so let's just go back because we're leaving grade 10 behind and we're starting to go to grade 11. And in grade 10, it was really about trigonometry, was a lot about that acronym and about finding sides and about finding angles. And all of a sudden, in the last lesson, we have this diagram called the cast diagram, or there's different ways of describing it. And what it suddenly allows us to do, and this is still a bit weird, is that if I say to you like the cos of 210, that makes sense. And yet, if you think about when we started trigonometry back in grade 10, it was all about right angled triangles where we had a reference angle over here. And you may ask yourself, okay, cool. But if I'm in a triangle, I thought all triangles add up to 180. So how can the cos of 210 even make sense? And that is what this diagram helps us with. But let's just use our calculators to see what do we get for the cos of 210 if we put it in our calculators. And then Gemma, your hand is up. Would you like to ask a question? I'll unmute you now if you would like to ask. Otherwise, you can just tell me it was just up from earlier. Gemma, do you want to ask a question? Yeah. Okay, no, it was just up from earlier on. So what I'm going to do is I'm going to lower your hand and then go from there. Okay, what do we get for the cos of 210? If we just put it in our calculators, is it positive? Is it negative? Is it a value? Is it not? I don't know. I actually just made it up on the spot. So what do we get for the cos of 210? We get a negative and we get a negative fraction. What fraction do we get, out of curiosity? Now, if it's a decimal, you want to change it to an SD, you hit the SD button. Give me a minus something. What is it? Minus square root 2 over 2. Okay. So what we see is if we put this in our calculator, we get that it is equal to and as a decimal, what is this as a decimal? Can someone tell me, hit the button so it's a decimal? I'm guessing it's between -1 and 1. In fact, I'm not even guessing. I know it has to be. Oh, Nicole said it was actually square root 3 over 2. I mean, okay. So square root 3 over 2. That sounds a bit better, yeah. What do we get as a decimal for the cos of 210 if we put that in our calculators? And I want everyone to do this because I take the time. Okay, so minus 0.87. Now, the thing that you'll notice about cos is that cos always, unless it's been changed in some way, will always go between -1 and 1. So that's why I knew we would be in that range. Now, what the cast diagram does is it predicts what the sign of this will be. And the 210, if we want to visualize this, 210 would start on this axis. So that's 0, that's 90, that's 180, that's 270, that's 360. If I start here, 210 gets me into quadrant 3. And the way that we get around the problem from before about what, if we're doing trigonometry, where are the triangles, is we actually draw a triangle in this quadrant. And we make a right angle triangle using the angle 210, but it's almost like we chop 180 degrees off and we just get left with this angle inside. And that's kind of the sneaky way we get around the problem of, even though the angle is bigger than 180, it only gives us a triangle with an acute angle inside because of the shape. Now, what we said in the last lesson was that the only trig ratio that's positive in quadrant 3, so we named the quadrants, and I'm just going over in case somebody has forgotten this. We call this quadrant 1, this quadrant 2, this quadrant 3, this quadrant 4. And in this quadrant, only tan is positive. All the other ones are negative. And since cos of 210 is in that quadrant, it had to be negative. But let's just test this out. If I now say to you, what is the tan of 210? What do we get for that? Now, it's going to be in the same quadrant. I'm interested to know its sign. I'm also interested to know if it's positive or negative. And my students will tell me in the chat there. What is it going to be positive? Is it going to be negative for the tan of 210? So it's definitely positive because, well, I mean, the calculator is telling you it's positive, but we kind of knew that because that's the whole point of the t. What is its actual number value? What is its actual number value? You can give it to me in decimals or give it to me as a surd. So Nomfundo has said it is square root 3 over 3. See if you agree and also give me the decimal. Okay, 0.58. Naledi has helped us out. And that I'm not going to check it. Well, actually, I can check it manually if I want. Let's go. Square root, sorry, fraction square root 3 over 3 is the same as 0.58. Okay, perfect. So I want to move on today to practice something called the reduction formula, okay? And the reduction formula basically just says, you see this 210, this 210 is made up of 180 plus the extra bit. And we can reduce any trig thing, which is a big angle, to a small angle using the idea of how much is the last little bit, like how big is the last little bit, and is it positive or negative in that quadrant? And that's all the reduction formula really is. And so in the last lesson, I can't remember if I did this with you, but I'll go have a look now quickly. We want to reduce these. Let's have a quick look at what we did in the last lesson. Oh, we didn't quite get there. We just started introducing. Okay, so we are now going to take these trig ratios and we are going to reduce them to equivalent but smaller trig ratios. And I'm going to do the first one with you, but there's one extra thing we need to add for the cast diagram. Is the cast diagram tells us where it's positive or negative, but it also tells us about the form of the angle. So if it's in this quadrant, it'll have the form theta, and theta is just a placeholder. Sometimes teachers use like another variable, but sometimes they call it the reference angle. But basically, these quadrants, if an angle is in this quadrant, it's going to have this form. So to show you what I mean, and we did this at the end of last time, if I want to take the sine of 163, that is in that quadrant. And the triangle that I formed to evaluate sine of 163 would look like that. But I can rewrite, the really important bit is this bit, and I can rewrite this as the sine of 180 minus, not 63, oopsie daisy. What am I going to write here? Maybe you can tell me. If I want to rewrite the sine of 163 as an equivalent thing, but in the form 180 minus, what does this missing yellow need to be? Keep it coming. So I think it has to be 17. Yeah, perfect. Now that 17 is this reference angle that is sitting inside the triangle. It's the really important value that's going to unlock the reduction. Okay, now, this is how awesome reduction is. You ask yourself, is sine positive or negative in quadrant 2? It's positive, so you make a big positive sign. Then you say, if you are using the nearest horizontal, and notice how my triangle is being formed with the nearest horizontal line. It's 180 degrees is what we're using. If I do that, I simply write down the same trig ratio, and then what I do is I write down what is the small angle or the reference angle, which is here is 17. So I'm going to make the claim to you that the sine of 163 is exactly the same as the sine of 17. Put that in your calculator and tell me if it's T for true or F for false. I want you to confirm that, in fact, the sine of 163 is the same as the sine of 17. And if I'm telling you a lie, say false. Okay. Good for me, good for you. Looks like I'm telling the truth. Now, if we look at the next one, what I want you to do is, if we look, but let me do it below where there's a bit more space. I'm going to work on number 2 now. What we're going to do is we're going to start by rewriting. What quadrant is this in? Cos 327. What quadrant do I think I'm in? 1, 2, 3, or 4? It's in quadrant 4. And in quadrant 4, cos will be positive. So I'm going to write positive cos, but I need to rewrite this in the format of that quadrant. So what am I going to rewrite over here so that basically I'm rewriting it in terms of the form of angles in quadrant 4? So how can we get, if we start with 360, what do we need to subtract so that we end up with 327? It's going to be 33. Okay. Now, it hasn't been reduced yet. You know it's positive, but I have still this really big angle floating around. But what is this going to reduce to? It's going to reduce to the cos of what? So the gorgeous thing is that, let me just actually visualize this angle for you. If you get to 327, you would go all the way around to here, and you would make a triangle with the 360-degree line, which means that the only angle that really matters in your triangle is that little 33. And so this would become the cos of 33. And you can test me on this. The cos of 33 is exactly the same value as the cos of 327. Okay, I want you guys to rewrite these last two in terms of the, so this is in quadrant 3. I want you to rewrite it, and then I want you to try and reduce it. And then the same with cos 213. I want you to try and rewrite it in terms of the angle formula, and then I want you to know if it's positive or negative, and then I want you to reduce it. So I'm going to give you 3 minutes to do these two questions and say, you need to reduce these trig ratios for me using what you've seen me do so far today. And you just say done in the chat when you are done. Okay. Let's go. After a while, these start to get a little bit easier because they start to feel more predictable. I'm pretty confident this should be 68, because it goes 180 plus whatever I need to do to get to here. So unless I'm making a silly mistake, this angle here should be 68. Does that give me? Yeah, okay. But now I still have to reduce this. In this quadrant, tan is positive, and so I would write this is the same as the tan of 68. So that's a much smaller angle, and yet it's the same value. See if you can do the next one. See if you can do cos 213. Can you reduce that? So 20 to get to 200, and then 13, so that's 33. And I've made a bit of a mistake. It can't just change to tan, it has to be cos. So What quadrant is that in? It's in quadrant 3, which means this should be minus. And how far away is it from the nearest horizontal? The only angle that really matters is this little bit here. We call that the reference angle. Give me a thumbs up if you followed what I've done. Basically, what I do is I rewrite the angles in terms of the quadrants, and then I basically look for the small angle, and then I make sure whether it's positive or negative. So give me a clear indication. If you don't get it, it's important that you tell me loudly and clearly, because I can't read your body language quite as well as I would in a physical space. So please let your feelings be known. I'm going to move on to a similar type of thing. In some ways, I think this question is easier. So this says, can you reduce the following trig expressions? But instead of having to find out what the missing little bit is, they tell you what's going on. So they say, can you reduce this? Now, 180 minus theta must be in this quadrant, because we recognize the structure of this. Here, over here is 180. Is this expression, now there is one assumption. The one assumption is that this theta must be acute. It must be less than 90. So that assumption is implicit. This angle has to be less than 90. Now, do we think number one is going to be positive or negative? Okay, now think about what quadrant am I in? So if I write down the cast diagram, in quadrant 2, sine is positive, which means this thing must be positive. Now, I want to ask you, this angular, so I know basically it's going to be positive sine something. The only question is, what is that sine going to be? So I'm going to ask you like this. How far away is this angle over here from the nearest horizontal? And remember, the angle is 180 minus theta. So how far away is it from the nearest horizontal? It's just going to be theta away. So it's almost like, remember before we'd write like 180 minus 30, like we'd write this. And then what we would do is we would say, well, this is the same as plus sine 30. But in this case, it's even easier because they just say it's a variable. Okay, now, using that idea, I want you to try and do number 2 and number 3. So you're going to try and reduce this trig expression, and you are going to try and reduce this trig expression to something smaller using the example from number 1 that I gave you and using the cast diagram. And I'm going to give you 2 minutes to do that. So knock yourself out there. Be the best that you can be. And while you do that, I'm going to get some water. And if you are like, this is my jam, like I was born for this, don't be afraid to do 4, 5, and 6. But for now, 2 and 3 are the compulsory ones. So 180 minus theta is still in quadrant 2, but the problem is it's cos, and cos is negative in that quadrant. So you get minus, and then the little bit that matters is still just theta. So number 2 is minus cos theta. But what quadrant is 360 minus theta in? What quadrant will that be? Okay, quadrant 4, absolutely. And the good thing is, in quadrant 4, Naledi, cos is positive. So we can go, that's just positive cos theta. Now, what I want is for everyone to try and do 4, 5, and 6 now. If you have a question, though, while students are doing 4, 5, and 6, I would love for you to raise your hand to ask a question, and I will gladly go over maybe a part that you don't know, or you can put your thing in the chat. But my experience is it's quicker to just ask your question audibly. It takes too long to type things out. It's quicker to just raise your hand and ask your question. And when you do that, it benefits not just you, but it benefits everyone else in the room. So think of it as your contribution to the group. Now, where is 360 plus theta? Oh, I know. 360 goes all the way around and then a little extra bit for the plus theta. So let's even visualize that. So all the way around and then an extra bit. And then my triangle kind of looks like that. In that quadrant, everything is positive. So it's plus cos theta. So what about 180 minus? So 180 minus is actually going to be in this quadrant, but tan is negative. And how far away is it from the nearest horizontal? Remember, this is 180. So 180 minus theta is just theta away. And so this will be minus tan theta. And then the last one looks the same as number 4. So the answer must be still cos theta. Give me a score out of 10 for your understanding. So for the reduction process, 10 out of 10 if you feel like I could do this. 0 out of 10 if you feel like you know nothing. Give me a score out of 10 about your understanding of reduction, just so I know how much further I can go in terms of this process. Okay, now, the good news is, if you still need more practice, remember, you can re-watch this lesson. And obviously, we're going to do more examples after the break. But in order to do the next examples, we need access to something called special triangles. And that's what we're going to do to just before our break. So there are 2 very important special triangles. The one special triangle comes from chopping up a square, basically, and it has 45 and 45 in it. And then the other special triangle comes from chopping up a equilateral triangle, and it looks like that. Give me a thumbs up if you've seen these 2 triangles. They're still missing information. If your teacher has mentioned them before, give me a thumbs down if you've never heard of these special triangles. I want to get a sense of if you've seen it before, if you haven't. If you haven't seen it, it's important maybe that you re-watch this next bit a bit more slowly. But so basically, what the first special triangle has is it's an isosceles right angle triangle, and it has 1, 1, and root 2 on its sides. And the other one is it always has a 1 opposite the 30. Then it has a 2 opposite the right angle. And then over here, it has a root 3. Now, what we're going to do after the break is we are going to use these triangles to evaluate things. So if I say to you, without a calculator, tell me what the cos of 60 is, or without a calculator, tell me what the sine of 45 is. Without a calculator, you need some physical representation of these numbers. So what is cos of 60? It's just a over h. But now I need values for a over h or x over r. So I go to this triangle over here and I say, look, in this triangle, when 60 is the reference angle, that is O, because it's opposite that. This is H, and this is A. So what is the cos of 60? Well, the cos of 60 is just 1 over 2. Put that in your calculator and just convince me that tell me T if I'm telling the truth and false if I'm telling lies. But according to this, the cos of 60 is just going to be 1 over 2. Fantastic. What do you think the sine of 45 is using this special triangle? So without a calculator, just using the drawing, what is the sine of 45 the same as? I want you to look at the drawing and think about what is the sine the same as? And what do I need to substitute? So sine of 45 is over h, and there's an O is 1, and h is root 2. Now, in your calculator, what your calculator does is it rationalizes the denominator. So it'll write this as root 2 over 2. But the whole point of this question was to use, no calculators. So after the break, what we're going to do is we're going to remix these special triangles with the reduction formula that you have learned about. And that's going to be the second half of the lesson. But it is now time for the best part of the lesson, which is the brain break. And we are going to turn our cameras on so that everyone can see us. And we are going to do some exercise together. So I want everyone on their feet with me. And even if it feels a bit cringy, just do it, because we are ultimately about learning. And we know that we as humans need oxygen and blood flow and all these awesome things to learn. So we may as well just get with the program. Okay. Everyone's standing up nice and tall. You want to feel nice and relaxed. Let's take 3 deep breaths. So breathe in. Take another nice deep breath. Oh, let me use my arms rather. And then one last deep breath. Okay, so I can feel the oxygen in my body. Let's just roll my shoulders back to just get any tension out of my body. Just roll your shoulders back and then roll your shoulders forward. So just loosen up your shoulders. You want to feel like you're relaxing. And in fact, let's shake out our arms to the nice and floppy. Shake out the other arm. Shake out the leg. You can't see my leg, but I'm shaking it. Shake the leg. Then let us put our arms out like this. Make sure there's nothing that you're going to whack into, and just lightly twist from the hips. And then as you relax, you will feel that your body will go further naturally. Yeah, I can feel myself feeling more loose. Okay, shake out those arms again. Shake out the legs. Let's do some tricep stretches. So up like this. And it actually feels really good. I think my left shoulder's a bit sore. And then like that. And then one last shake. Shake this arm. Shake that arm. Let me shake that leg. Shake that leg. Okay, now it's time for some heart rate raising stuff. So we do jumping jacks. This is a jumping jack, and we are going to do 15 of them. We start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I feel like my body has said, look, I will give you 20 more minutes of concentration because you have taken care of me. And then just before we head back to class, let's just do one little fun puzzle. So can you make 24 using those numbers? That is your challenge. That is your challenge. And this isn't too bad, actually. I feel like we'll get this. Well, actually, no, maybe not. Who knows how to get to 24 using these four numbers? Now is your time to claim the glory. I'll give you one hint to start. 7 plus 1 is 8. So I've used up those two numbers. What do I have to do after that to get, using these two numbers, to get to 24? Who will be our Maths 24 champion for today? It could be you. It could be you on the podium. Aha, I see some answers coming in. Callan, I think, oh, you got even better way. 7 minus 1 is 6. And then 6 times 4 is 24. And then you just divided the 24 by 1. Perfect. All I was going to do is I was going to say 4 minus 1. 4 minus 1 is 3. And then I was going to times 8 by 3 to give me 24. And I think Pilar has done the same, which is awesome. Okay, let's go back to our lesson. So we were dealing with the reduction formula. We were dealing with special triangles, and we won't worry about that too much. But let's see how we can deal with, or maybe, okay. I want some class participation here. This is a multiple choice question. It says, what is the exact value of the cos of 240? Now, the problem is that's a really big angle, and I don't have any triangles that have 240 in them. So what do you think we should do first? Before we can even begin to guess A, B, C, or D, and we're not allowed to use a calculator with this question, what should I do first? Who would like to tell me? Put your hand up and you can give me a quick little snippet of advice that we can share with the class. Okay, let's go to Buchle. Buchle, what would you do?
So we first have to reduce this.
Okay.
We have to make it an acute angle. So minus cos 240 would be in the third quadrant.
Okay.
And that is 180 plus. So we'd say 180 plus 60.
Perfect.
And that is a special angle.
Okay, before that, it's negative. So can you reduce it? So would you get minus cos 60? Is that what you
Yes,
got?
sir.
Okay, perfect. Now, how are you going to evaluate? If I say no calculators are allowed, what are you going to use to help you get at that 60 or evaluate? The minus is fine, but you still have to do this.
Then these are special triangles, sir. So we know that 60 is a special angle.
Okay.
Our 60-30 triangle. So then we have 60 on the one side, 30 on the other side. And then because it's cos,
Yes.
the ratio is adjacent over hypotenuse. And
Okay.
because cos is negative in the third quadrant, then it's going to be minus 1 over 2.
Yeah. So basically what Buchle spotted is that this would be the A, and this would be, let me use a highlighter rather. This would be the H, And then the minus comes from what quadrant it's in. So the correct answer, Bukle, would be C. Did you get C? Okay, I think I'm pretty confident Bukle agrees with me here. All right, so that's a basic idea of a question. Let's try and do this one. Which acute angle has the same tangent as 220 degrees? A, B, C, or D. Now, when they say tangent, they mean the same as which angle less than 90 has the same value. So the tan of what equals the tan of 220 is another way of phrasing this question, where you're trying to figure out what that thing is. Tell me which of the four you think it is. Which one of the four do you think it is? So if we go back to what we were doing earlier in the lesson, it feels like this can be written as that. So what do we think that's going to be? It feels to me like in that quadrant, tan is positive, so there's no problem with that. But the magic thing is the 40. That's the reference angle. That's the little bit that's going to be hiding out over here, making my triangle. And so the correct answer should be A. And you can try that on your calculator and you'll see that it's true. Okay, now things are getting a little bit more exciting. So let's have a look at, this is a typical test or exam question. So it says, determine the following without the use of a calculator. And I am going to do the very first one with you. And then you are going to do number 2 for me by yourself. So if I want to evaluate without the use of a calculator, that is code for saying I need to use special triangles. But at the moment, the problem I have is I have no special triangles with 150 in them, and I have no special triangles with 330 in them. So in fact, I'm not going to do this whole thing. What I'm going to challenge you to do is I want you to rewrite this number 1, except I want you to make the tan of 150 smaller, and I want you to make the cos of 330 smaller, and then I want you to write down what you've got. And when you're done with that, I want you to say done in the chat, so I know you're done. But I'm going to give you at least 2 minutes to do this. See if you can reduce the thing in green. So the tan of 150 is making my life difficult, and the cos of 330 is also making my life difficult. The sine of 30, I don't mind. That I can deal with because I know I have a triangle that has that in. So just say done when you're done with reducing those two. So for those who want to do a couple of extra steps, what I probably would do is I would start by just rewriting this like this. Now, when you do these multi-step questions, well, there's lots of them, you don't have space to do them all in a separate line. So what I start by doing is just rewriting it in the form of the quadrant it's in. So I knew 150 is in quadrant 2, so I wrote it as 180 minus. This one is the fourth one. But the next step, I have to say, in that quadrant is tan positive or negative. And in quadrant 2, tan is negative. And then I'm going to write minus tan 30, because the only bit that really matters is this extra little bit over here. The sine of 30 is just saying the sine of 30. There's no need to reduce anything. And then the cos of 360 minus 30, well, in the quadrant 4, cos is positive. So all I need to write is the cos of 30. So really, this question can be rewritten like this. And what I'm noticing is that all of them have 30s. So I think all of them are going to have to deal with this triangle over here. And what your task now is to do is you need to fill in all the missing brackets that are there and then get me a final answer. So what's going to be your final answer? I'll give you another minute to try and get to that, and then we'll get going with number 2. So I want to know what goes there, what goes there, what goes there. Remember, no calculators, huh? I hear some calculators in the background. So O, opposite. So tan is, just in case we've forgotten, it can be helpful to write down tan is O over A. So opposite 30 is 1. But now the other one is A. Now it can't be the H, so this must be over that, like that. But you have to fill in the other 2 ones. Now what's the other? Sine of 30 is 1 over 2, because opposites, hypotenuse. Cos of 30 is going to be, so now be careful, that's going to be O, that's going to be A, that's going to be H. That means that cos of 30 is root 3 for the A over 2. Does everyone get that? And from that point, okay, I'm actually not going to, you can neaten this up by putting them together, but I'm not going to go into that right now. Or maybe I should. Okay, it's probably more difficult than I need to do at this stage. But I just want to see that you get to that point. Give me a thumbs up if you followed me doing the reduction of the yellow, blue, and green, and then you saw how I filled in the values. Just give me a thumbs up and see if you can do that. I want to see some voting so I know how you're feeling. If I'm losing you or if you followed me as I'm going. Okay, so I'm going to finish this last bit off for you just because I can, but we have limited time. So when the minus comes inside, I'm just going to put the minus to the top, and then I get 2 root 3. Now, if you use your calculators here, but you're not allowed to, that's the thing that makes it hard. So you know what I'm going to do? I'm going to be sneaky, and I'm going to multiply the top and bottom here by root 3. And the reason I'm doing that is I really want both of these to have the same denominator. Because if they have the same denominator, and the other funny thing is root 3 times root 3 is 3. And then, because I have the same denominator, I can just then go minus 1 plus 3, which is 2. But now we have a 2 on the top and a 2 on the bottom, which is just 1 over root 3. Now, I don't want you to stress about that. That was some pretty snazzy fraction work I was doing there. But I just wanted to show you that without a calculator, that's kind of what you would have had to do. But you would have got 5 out of 6 marks or 6 out of 7 just getting to that step. So really, I'm not going to lose any sleep over that little bit of fraction magic that I did there. Okay, last question for the day. Can you please simplify this for me? Simplify this expression over here, and then I think we're going to call it a day for today because we've done a lot of good work, and I'd rather have you absorb it than try and do too much. Now I'm going to start by rewriting this in terms of a quadrant 4 angle, and then this one in terms of a quadrant 2 angle. So all I'm doing is writing it in the right form to make my life easier. Now, I made a mistake because I wasn't paying attention. That should be minus 60, and that should be minus 60. Okay. Tell me when you're done in the chat, when you are done with that. And remember, we have to evaluate without a calculator. So quadrant 4, tan would be negative. So minus tan 60. Quadrant 2, cos would be negative, because it's quadrant 2. So yeah, that's correct. And a negative times a negative is actually a positive. So all we need to do is evaluate those two expressions. And for that, I need to go to my special triangle. And because I've been doing this for so long, I'll just do one down here. My brain still seems to have it on available. So 2 root 3. What is the tan of 60 times the cos of 60? So that would be O, H, and A. So this should be root 3 over 1. And then what is the cos of 60? Well, it's going to be 1 over 2, which gives me a final answer of root 3 over 2. And that is that. Okay, so what did we do today? We looked at how we could reduce trig ratios that have big angles to smaller trig ratios where the value is the same, but the angle is smaller. We also looked at how we can take that smaller value and evaluate it using a special triangle. And that is, honestly, in an exam, you pretty much get 10 marks for that, 10 to 15 marks for that every exam till the end of matric.